Did you ever pause and ponder on the different types of wireless networks that enable our daily digital interactions? It's a fascinating world, one that's often overlooked. Wireless networks, invisible yet imperative, weave the fabric of our modern digital lives. From enabling a simple text message to a video conference across continents, they are the unsung heroes of our connected world. Understanding these networks isn't just for the tech-savvy. It's for anyone who wants to grasp the magic that happens when we tap send on our screens. We're talking about wireless local area networks, wide area networks, metropolitan area networks, personal area networks, and the intriguing world of wireless mesh networks. And let's not forget the unique properties of the 5 GHz band. Each type of network plays a pivotal role, and understanding them helps us appreciate the complexity and beauty of our interconnected world. Today, we'll delve into the fascinating world of wireless networks. First off, we have wireless local area networks, more commonly known as WLANs. Now, imagine a bustling cafe where people are sipping their coffees while browsing the internet. A busy office where employees are collaborating on a project. Or even a cozy home where a family streams their favorite shows. What's the common thread here? It's the invisible yet essential presence of a WLAN. WLANs are a type of wireless network that allows devices to connect and communicate within a local area, such as a home, school, office, or small geographical area. This is typically achieved via radio or infrared signals that transmit and receive data from a central hub, often a router. One of the most popular examples of a WLAN is Wi-Fi. Wi-Fi, short for wireless fidelity, is a technology that uses radio waves to provide wireless high-speed internet and network connections. It's become so ubiquitous that we often use the terms Wi-Fi and WLAN interchangeably, even though Wi-Fi is technically a type of WLAN. The beauty of WLANs lies in their flexibility. They allow multiple devices to connect simultaneously, enabling seamless communication and data sharing within the network. Whether it's sending a quick email, streaming a high-resolution video, or controlling your smart home devices, WLANs have got you covered. But it's not just about convenience. WLANs can be a cost-effective solution too, eliminating the need for expensive and cumbersome cabling. In essence, WLANs provide wireless network communication over short distances. Moving on, let's talk about another type of wireless networks. Wide area networks, or WANs. This network type is quite the powerhouse, covering vast geographical areas, from cities to entire countries and even continents. Imagine the vast expanse of the internet, a classic example of a WAN. WANs are a key player in ensuring that devices far and wide can communicate regardless of their physical location. They connect smaller networks like LANs and MANs, creating an interconnected web of communication that spans the globe. Now you might wonder, how does a WAN operate? The magic lies in the use of routers, switches, modems, and dedicated leased lines, or through more contemporary methods like satellite systems and cellular data networks. These components work in harmony to transmit data across long distances. Speaking of cellular networks, they are a popular example of WANs. They employ multiple antennas called cell towers spread across a large area to provide coverage. When you're using your mobile device to call a friend or browse the internet, you're utilizing the power of a WAN. But WANs aren't just limited to cellular networks. They also encompass satellite communication systems, cable systems, and more. These networks are the invisible threads that weave together our global communication infrastructure, making it possible for you to watch this video, no matter where in the world you are. WANs, in short, provide network communication over large geographical areas. Now allow me to introduce 2 more types of wireless networks: metropolitan area networks and personal area networks. Firstly, metropolitan area networks, commonly known as MANs, are larger than local area networks but smaller than wide area networks. They are designed to extend over a city or a large campus. You see, they provide the perfect solution for businesses, government bodies, or education institutions that need to share data across various locations within a city. Imagine a citywide hotspot where you could roam around the entire city without losing your internet connection. That's a classic example of a MAN. It's like having a giant invisible web spun across the city, connecting various points to a central network. Isn't that fascinating? Now let's shift our focus to something a tad bit smaller in scale. Personal area networks, or PANs. As the name suggests, these networks are designed for personal use or within a small area. They allow devices to connect directly to each other without needing a central access point, making them ideal for small-scale, short-range connections. Perhaps the most widely recognized example of a PAN is Bluetooth. You know, the technology that lets you connect your phone to your wireless headphones or your laptop to a wireless mouse. It's so ubiquitous you probably use it every day without even realizing it's a type of wireless network. In essence, PANs are all about creating a network of personal devices that communicate with each other directly. From smart homes where your phone controls everything from your lights to your thermostat, to a simple connection between your laptop and printer, PANs are the invisible threads that connect our digital lives. So while MANs cover citywide areas, PANs are designed for personal or small-scale use. It's all about choosing the right network for the right scale and purpose. It's a fascinating world, isn't it? Wireless networks, in their many forms, are truly transforming how we live, work, and play. Next up, we have wireless mesh networks and the 5 GHz band. Let's dive into the concept of wireless mesh networks first. Picture a net where each knot is a wireless device, like a router or a laptop. Each of these knots or nodes can communicate directly with each other, creating a web of connectivity. This is the essence of a wireless mesh network. They're flexible, robust, and resilient. If one node fails or loses connection, the network can automatically reroute data via other nodes. This self-healing ability means fewer interruptions and more reliable service. Now you might be thinking, this sounds great, but how does it handle high data demands? That's where the 5 GHz band comes into play. The 5 GHz band is a spectrum of radio waves used for high-speed wireless communication. Compared to its counterpart, the 2.4 GHz band, the 5 GHz band is like a highway with more lanes and less traffic. It can support more devices at faster speeds and with less interference. However, there is a trade-off. The 5 GHz band doesn't travel as far or penetrate walls as effectively as the 2.4 GHz band. But in a well-designed wireless mesh network, this isn't usually a problem. The nodes are close enough together to ensure a strong signal throughout the network. So when we combine wireless mesh networks with the 5 GHz band, we get a network that's not only resilient but also high speed. It's perfect for environments where a lot of devices need to connect, like offices, homes, or public spaces. And it's not just about speed and reliability. The 5 GHz band is also less crowded, which means less interference from other devices. This is especially important in areas where a lot of wireless networks coexist, like apartment buildings or commercial areas. In conclusion, wireless mesh networks and the 5 GHz band are more than just buzzwords. They're powerful tools for creating robust, high-speed wireless communication that can adapt and grow with our ever-increasing connectivity needs. Wireless mesh networks and the 5 GHz band are crucial for robust, high-speed wireless communication. Lastly, let's compare wireless networks to their wired counterparts. When we examine the installation process, wireless networks have a clear advantage. They require no physical connection between devices, eliminating the need for extensive cabling. This makes the setup process quicker and less invasive, especially in historical buildings or places where drilling into walls is not an option. On the other hand, wired networks require the installation of Ethernet cables, which can be time-consuming and costly. However, this upfront investment in infrastructure often leads to increased network stability and less interference from other devices. Next, let's look at speed. Wired networks can generally support higher data transfer rates compared to wireless ones. The most recent Ethernet cables, for example, can support speeds up to 100 gigabits per second. In contrast, even the fastest wireless networks typically peak at a few gigabits per second. Now, onto reliability. Wired networks are less susceptible to interference and therefore tend to be more reliable. They're not affected by physical obstacles like walls or other electronic devices. Wireless networks, however, can be disrupted by a myriad of factors, from other wireless devices to microwave ovens. Finally, let's consider security. Wired networks are inherently more secure as they require physical access for unauthorized connections. Wireless networks, while having made significant strides in security protocols, are still more vulnerable to attacks. Anyone within the network's range can attempt to connect, making it a more attractive target for hackers. In summary, both types have their own set of advantages and disadvantages. Wireless networks provide flexibility and convenience, ideal for environments where mobility is a priority. Wired networks, on the other hand, offer superior speed, reliability, and security, making them a preferred choice for businesses and data-sensitive operations. While wireless networks offer flexibility and convenience, wired networks are often more reliable and secure. In the digital era, understanding wireless networks can be quite empowering. From local area networks that connect devices in a small vicinity to wide and metropolitan area networks that span cities and countries, the scope is immense. Personal area networks offer connectivity for personal devices, while wireless mesh networks and the 5G HZ band provide robust high-speed connections. And remember, while wired networks have their place, the flexibility and convenience of wireless connections are unmatched. And with that, we conclude our journey through the world of wireless networks. Remember, the future is wireless.